Good morning, neighbors. This is a question about alpha particles. Fundamentally, the only alpha particles we talk about are from nuclear releases, but there are alpha particles from space. Some of those alpha particles from space have some very unique things you could talk about and around. Others will stick them in here, I'm sure. But we're talking about alpha particles from nuclear decay. Very specific particles, very specific measurement science. It's not beta, it's not gamma particles, they're alpha. You could go get a PhD just talking alphas, and there's folks out there that are very well capable of doing that. It's huge. It's a massive undertaking inside of just that alpha particle and what it does, how it works. It's medical sciences. It's how those alpha particles, those beta particles, can be put into a human body and actually kill everything so that you can start over again. That's what chemotherapy does. And the doctors that do chemotherapy know very much about chemotherapy and medical isotopes and radiation's effects in a medical environment. That's what they're trained for. They spent how many, 6 to 10 years likely to get to where they are inside that profession? So, alpha particles. The simple question is, how far do they travel? I've seen that a few times, and I've seen very educated people say it's centimeters to meters. So there's something going on there. It's not a disparity, it's a clarity in communications. That alpha particle in space, with very few things to run into, will travel a great distance in a vacuum. When the alpha particle is in a mixed environment, the same as light. Light has the exact same behavior properties. In space, it travels. There is very little attenuation of that light. As soon as it hits our atmosphere, that attenuation, that interferometry, how things run into each other and works begins to come into play. So the travel distance of that alpha particle is anywhere from centimeters to meters. Knowing that now, having an idea that's how it works, it's not absolute. You don't all of a sudden walk into the field. You gradually step into the field as you walk towards, if it is a point source somewhere. You walk towards that greater energy dissipation. But go back to that distance traveled. If it is centimeters or even feet, that your meter is detecting those elements, these alpha particles, it means those elements are in the air. They're in the atmosphere. By what we just said, in order for you to detect them, that particle has to have decayed or disintegrated within a few millimeters or a few inches or a few feet of your body. That's an exposure path. You can carry that notion just a bit further because not only is it external, those particles are in the air. It is now an internal dosage. You have now received 2 dosage types. The dosimetry is different. The rules change on internal versus external dosimetry. The rules get much more complicated because of how these interactions are. That subatomic particle, that alpha particle that we're specifically talking about, it is a major constituent of nuclear release and waste. If you go look at the release inventory, not the single element that folks point to in most of these nuclear accidents, it's informing, it's educational. It gives you a hint to what I'm trying to talk to and about, because the decay lives of all of that inventory are important. the biological uptake paths, where it's likely to go. The sedimentation, the physical separations of these things happens up in the mountains, in the forests, and washes down in the rainwater. You could compare this to panning for gold, only it's a different type of gold. It's more expensive than gold if you're in that field, so that's enough time for alpha. Alpha particles by themselves are doctorates and PhDs. You're playing in the land of possibilities for medical delivery solutions to healing potions and magic inside your body. Only magic isn't the word for it. We'll go on. We'll get better. Keep doing what you do. Alpha out.